Today's lesson is on algebraic solutions of trig equations. So today we're really going to address the issue of, well, what if I have an equation for which the value is not one of those values that is a memorized value? So for example, what if it's not root 2 over 2 or 1/2 or 1 or 0? Then what? How can we, does that mean there's no solution? Or is there another way to solve those? So today we're going to address that for sine, cosine, and tangent, and we're going to just fill out this chart, and we're going to find out how we can solve for those values. So the equations here are written on the left. We have sine of x equals c, cosine of x equals c, tangent of x equals c. So c is just some value, some constant value. And technically you can use it even if this chart will be useful for any possible value of c, even if it is a memorized value. Now, the memorized values, what's nice about those is that it comes out to be exactly a specific, like pi over 6, for example. Whereas for these ones, you will have to put it into the calculator, and from the calculator, you will be able to get the correct answer, but it won't be exact, right? So pi over 6, if you plug that in, it's going to be a little bit more than 0.5 radians, and it will come up with a number of decimals, and it won't be an exact answer. So we try to be exact when we can, but when we can't, that's when we use this. Okay, so just know that it technically does work with all those memorized values, but we want to keep using those memorized values the way that we have been, because those are exact answers, whereas for these values, we want to at least be able to get some sort of value, even if it's not a memorized value, we want to get some value that is actually useful. So let's look at sine of x equals c. So there are two possible values for c. Either c is between -1 and 1, or it's not in between that. So when c is between -1 and 1, inclusive, then you've got two, we're going to call them solution sets. So the first solution set is sine inverse of c plus 2k pi. Now what is this plus 2k pi? It just means that you can plug in any integer value for k, and it will also be an answer, right? Because if you add, say, k is equal to 1, plus 2 pi means you've rotated a full rotation around. If you have k equals 2, you have 4 pi, which means you rotated 2 full rotations around. So just know that these solutions are solution sets because there are actually an infinite number of solutions, but we don't want to have to write them all out because it is an infinite number of solutions. So the best way to say it is to say sine inverse of c, whatever that value is. If we add 2k pi, some multiple of 2 pi to it, that will also be a solution. Okay, the second one is x equals pi minus sine inverse of c plus 2k pi. Okay, and then the other possibility is if c is outside of -1 and 1. When that happens, now if you remember when we worked with the domain of the inverse, right, we said that it had to be between -1 and 1. So if it is outside of -1 and 1, then you can just say that the solution is no solution. There's not going to be a value of x that will satisfy that equation. So if you see sine of x equals 3, you know right away there's no solution, there's no value of x that will give me 3 because that's outside of -1 and 1. All right, on to cosine. So cosine of x equals c, you can see that we also have two different possibilities for the values of c. Again, c has to be between -1 and 1 for us to get an actual solution. So for the solution set here, we have x equals cosine inverse of c plus 2k pi, so same sort of thing. If you add any multiple of 2 pi, that will also be a solution. You've just rotated however many times around fully. And the second is x equals negative cosine inverse of c plus 2k pi. All right, and then just like with sine, if c is outside of that, if c is greater than 1 or less than -1, then there is no solution. All right, and the last one, tangent of x equals c. Possible values of c. Well, c can actually be anything. As long as it's a real number, we can find a solution for it. So that's one thing that's different between sine and cosine and tangent. So both sine and cosine, in order to get actual solutions, c has to be between -1 and 1, whereas with tangent, c can be any number. So if you remember when we talked about inverse tangent, the domain of inverse tangent had to be between -infinity to infinity, so that's all real numbers. Okay, so the solutions for this is also different from sine and cosine, is x equals tan inverse of c plus k times pi. So that just means that the values for tangent are actually going to be, are going to have what we call a shorter period. So sine and cosine, every 2 pi, those numbers start repeating itself again. But for tangent, every pi, so every half a rotation, you'll start repeating those values again. So whatever tan inverse of c is, put that into the calculator, and then if you add 1 pi, 2 pi, 3 pi, any multiple of pi, that will also be a solution. So again, the solution set is tan inverse of c plus k pi. The last thing to note is to make sure that your calculator is in radian mode. All of these answers that we're giving are in radians because we are adding that plus 2k pi. If you're finding it in degrees, you are technically coming up with a solution, but then you cannot write plus 2k pi. You would have to write something like plus k times 360 degrees, because it's every 360 degrees it'll repeat itself again. Okay, so let's go ahead and jump right into some examples. So solve cosine of x equals 0.6. Okay, so double check. Is 0.6 between -1 and 1? It is, so we can go ahead and find the solutions. So the first solution set is cosine inverse of c plus 2k pi. In this case, c is 0.6, so cosine inverse of 0.6 plus 2k pi. Plug that into the calculator, make sure you're in radian mode, and we should get that it's about 0.9273 plus 2k pi. Do the same thing with the other solution set. X equals negative cosine inverse of c, which is 0.6 plus 2k pi. Now, we actually already found cosine inverse of 0.6, so negative cosine inverse of 0.6 is simply the negative 0.9273 plus 2k pi. And those are your answers. Those are your solution sets. Now make sure you remember that these are not, these are solution sets. We are trying to say that 0.9273 is a solution, 0.9273 plus 2 pi is a solution, 0.9273 plus 4 pi is a solution, and so on. All right, example 2. Let's do one involving sine. Sine of x is equal to negative 0.75. Is negative 0.75 between -1 and 1? It is. Good. So then that means we can find solutions for it. If it wasn't, if say you had negative 1.75, you can actually just stop right there and just say there's no solution because that value is not between -1 and 1. Okay, in this particular instance it is. So we have x is equal to sine inverse of c plus 2k pi. X equals pi minus sine inverse of c plus 2k pi. All right, so we have sine inverse of negative 0.75 plus 2k pi. Plug that into the calculator. That's equal to 0.8481 plus 2k pi. For the second one, the second solution set, we do pi minus negative 0.8481. And that comes out to be about 3.98 or so, plus 2k pi. So those are our two sets of solutions. Now, if you're wondering, why is it this pi minus thing? Why is cosine also negative cosine? Remember that this is really just coming up with the solution sets that are in different quadrants. So for example, when we were working with values that you had memorized, right? You could have answers in multiple in multiple quadrants. So that's really what we're doing here. So for example, we knew that sine of pi over 4 is equal to root 2 over 2. Sine of 3 pi over 4 is also equal to root 2 over 2. Now, what's the difference between pi over 4 and 3 pi over 4? Well, to get 3 pi over 4, you're really just doing pi minus pi over 4. So really this is just keeping it between quadrants. So in this particular case, whereas sine is negative in quadrant 3 and quadrant 4, and so having that pi minus sine inverse is actually just finding the other one in the other quadrant. Same with cosine. All right, another example, this time with tangent. So tangent of x equals 3. Now, you might be looking at this and thinking, well, 3, that is outside of negative 1 and 1. But that's okay, because for tangent, there is no restriction on what our value c has to be, right? C, as long as it's a real number, we are going to be able to find a solution. Okay, so x equals tan inverse of c plus k times pi. So we're plugging in 3 for c, plug that into the calculator, and we have x equals 1.249 plus k pi. Okay, and that's it for today.